a product that's trying to receive UL 9540 certification will first undergo 9540A testing. Those test results will be used to design the product and system or make adjustments to the product or system level engineering or design based on the data we collect from 9540A testing. And then we'll go back to UL to apply for our UL 9540 listing. To start, we're at the cell level. Here, we've really broken down our energy storage system into its most basic unit. We've stripped away the enclosure. We've pulled out a single module. From that module, we've pulled out a single cell. So again, the most basic unit of our battery system. What are we trying to do at this cell level? Fundamentally, we want to drive that cell into a thermal runaway reaction and then evaluate what happens. You'll notice on this slide and the following slides, they're all going to follow the same format. We'll show you at the top the performance criteria, so what we're looking for at each level of the test.
LFP carries with itself inherent thermal runaway and therefore fire and explosion risk. It may be different in the amount of risk, but it is not a different category of risk. So just want to point this out real quick. On the right-hand side, you've got some orange dots and some blue dots, right? NMC here, the x-axis is going to be density, energy density, and the y-axis is going to be onset temperature. This onset temperature here is thermal runaway onset temperature. And so what you notice here is that not only is the circle of orange dots that relate to LFP higher temperature-wise, but they're actually a lot tighter grouped, which is to say less volatile, less or more predictable, perhaps, around the temperature at which thermal runaway might begin. So that is in part why we moved away from NMC. This is also to say that there is a risk. It is a non-zero percentage risk for thermal runaway and some of the specifically explosion risks that come with lithium-ion batteries.
If we think back, going through the unit level test, our setup for that is that we have an initiating unit surrounded by adjacent target units with a separation distance based on what the manufacturer thinks is safe or what they would like to include in those installation instructions. That could be 6 inches, it could be a foot, it could be 3 feet. Whatever they deem that they want in their installation instructions is the spacing they'll use at the unit level. If they're able to meet the performance criteria at the unit level, they can include that reduced spacing in their installation instructions. But, as Tyson also noted, AHJs are not necessarily required to accept that reduced spacing. They shall permit it, but they're not required to. So getting into some real-world examples of what that could look like, here's an actual letter from the San Jose Fire Department in California. This is not the only letter that we've seen from AHJs, but it is a great one. We really like the wording that they've used here, the path that they take through code. We hope will resonate with our students here, and it's many codes and standards that we've looked at earlier in this class. This is, again, coming from San Jose. We've seen at minimum 4 or 5 of these similar letters in other AHJs in California. And as a leading market for energy storage, it is important that we listen when AHJs in California in particular have an argument to make. We're expecting this to take off beyond California if it's not already spreading to other AHJs. So I'm going to read through part of this letter, do a brief summarization, and then I'm going to toss it to Tyson to really dive into the nitty-gritty of the codes that they're pointing at in particular.